नजर आ रही है सबको प्रेजेंटेशन?
यस सर।
प्रेजेंटेशन नजर आ रही है?
जी सर।
जी सर आ रही है।
Okay, as we have already discussed about the stationary phases and a mobile phase in thin layer chromatography, right? We have already tell you that more polar substance bind strongly to the adsorbent and elute slower. Less polar substances bind weakly to the adsorbent and elute faster. We have already discussed in our previous lecture that this is the mobile phase. The silica gel is bound with the compounds, right? मोर पोलर वाले ज्यादा बाइंड होंगे, लेस पोलर वाले कम बाइंड होंगे। मोर पोलर वाले स्लोली मूव होंगे मोबाइल फेज के साथ, और लेस पोलर वाले फास्टली जो है वो मूव होंगे। ओके, we have already discussed these all details. We have discussed the RF values in our previous lecture. You can visit in YouTube, right? So we have discussed the material used, and we have already discussed about the stationary phases and mobile phases, right? Okay, if we are try to compare the polarities, if you compare in hexane, butanol, chloroform, and methanol, methanol is more polar than other solvents. If you compare the first four solvents, right? But acetonitrile is more polar than others. We will discuss today the experimental procedure of thin layer chromatography. Basically, we have commercial TLC plates, glass plates as well as plate sheets. So you see here, this is TLC glass sheet, thin layer chromatography की जो glass sheet है. It is already coated commercially by silica gel. You can see here, ये already TLC जो है ये coated है by silica, right? लेकिन if you want, you can also prepare by your own. इसको आप खुद भी आप बना सकते हैं. How you will prepare it? The method is used to apply adsorbent. The adsorbents include silica or alumina, right? Initially, you prepare the celeries and binding agent and try to separate on TLC plate and spray it and dipping in a plate in celery. Suppose TLC plate preparation, TLC plates are usually commercially available with standard particle size ranges to improve reproducibility. So this is a commercially available one, right? Here, particle size is already mentioned in our TLC. You see here, so this is the TLC marks, TLC standard, TLC, right? They are prepared by mixing the adsorbents such as silica gel with a small amount of inert binder like calcium sulfate, that is also called gypsum, and water, right? The basic substance is silica gel, which is stationary phase. So it can we are using an inert binder, that is calcium sulfate, that is also called a gypsum, and with water. This mixture is spread as a thick slurry on an uncreative carrier sheet, usually glass or thick aluminum foil like this one, or plastic. The thickness of adsorbent layer is typically around 0.1 to 0.25 mm of analytical purposes. And if you want preparative TLC, we are using 0.5 to 2.0 mm for preparative TLC, right? सिलिका जेल की लेयर जो है वो 0.5 से 2.0 फॉर प्रिपरेटिव TLC क्वांटिटेटिव एनालिसिस के लिए हम करते हैं. Suppose you see here material use in TLC. Suppose this is a glass. If you want to prepare by your own, spreading the TLC by hoopers like this one, you see here, you can spread the slurry on it. Silica TLC is ready for you. Now you draw a line, bottom line. This is the bottom line, and this is the mobile phase solvent. which is called a developing chamber. This developing chamber is also called a TLC tanks. There are different sizes of TLC tanks available in market, right? Uh, so initially you draw the baseline and you just right now activation of plate is important. If you prepare by your own like this one, like this method, if you prepare by your own, you need to activate this plate before using for separation. How you will activate this plate is kept under kept for drying in oven at 100 degrees centigrade, right? To activate a plate, to activation of plate. This step is called activation of plate. By doing this, why we are try to activate the plate? What is the purpose of activation? By doing this, surface area of the adsorbent increases, right? Now, drawing a line and a circle to apply the sample at the bottom line. At the bottom of the TLC plate, draw a line like this one, right, by lead pencil and a circle to apply a sample. This circle is not much greater than the capillary. कैपिलरी में जो आपके पास सैंपल आएगा आपने इतना ही छोटा सा सर्किल करना है. This circle is used to apply the sample, right? And now experimental procedure में TLC chamber की preparation आप देख लें. Cut the filter paper first. As you have a TLC plate. इस पूरे को आपने यूज नहीं करना है. You need to cut it into pieces according to your need. So cut the filter paper so that it fits in the jar, touching the bottom. To ensure that the filter paper will work, right? Remove the if above criteria are met, then plate does not make any contact with the filter paper, then setup should work. Remove the TLC plate and then completely saturate the filter paper. Fill the jar with development solvent. Basically, you have to write the procedure from here. Fill the jar with the developmental solvent to a depth no greater than 0.5 centimeter. 0.5 सेंटीमीटर से ग्रेटर नहीं होना चाहिए ताकि ये आपकी बेस लाइन है. इससे ऊपर सॉल्वेंट नहीं होना चाहिए, इससे नीचे होना चाहिए. इस टीएलसी टैंक के अंदर सॉल्वेंट जो मोबाइल फेस है वो इससे नीचे होना चाहिए. सो फिल द TLC tank or jar with development solvent to a depth no greater than 0.5. Put the lid on the jar to preserve the saturated solution. You have to, once you dip the TLC on this TLC tank, you must lid it. इसको close करना है ऊपर से आपने. Application of sample. How you will apply the sample on this TLC plate? Spotting the TLC plate first, like this one, right? First you draw the line, then spotting it by lead pencil. Then dip the open end of the capillary into the solvent containing the compound to be eluted. जो compound आपके पास solid में है, इसको आपने किसी solvent में dissolve करना है और इसके अंदर capillary dip करना है. Dip the open end of the capillary tube into the solvent containing the compound to be eluted. जिनको आपने separate करना है, mixture है, इनको आपने capillary से just इसके ऊपर load करना है. Touch the end of the capillary tube lightly, very lightly, and very briefly to the coated surface of the TLC plate at the bottom, right? Your spot should be made on the line drawn across the plate in the correct length, and it should not have diameter much larger than the capillary tube. ये जो circle है आपने बहुत बड़ा नहीं लगाना है, ठीक है? You just इसमें your spot should be made on the line drawn across the plate in the correct length, and it should not have a diameter much larger than the capillary tube. After spotting the plate, place it in saturated chamber and close the lid. इसके बाद आपने ऊपर से इसका lid जो है वो आपने बंद करना है, ठीक है? Fill the jar with development solvent to a depth no greater than Substance should be eluted until the solvent front reaches a height of about 0.5 centimeter from the top of the TLC plate. इस सॉल्वेंट को हमने 0.5 ऊपर से हम मेजर करें तो 0.5 रहना चाहिए। आपने मुकम्मल ऊपर नहीं जाना चाहिए। सॉल्वेंट फ्रंट आपका 0.5 तक यहाँ पे इससे नीचे आ जाए तो आपने स्टॉप करना है। ठीक है। Substance should be eluted until the solvent front reaches a height of about 0.5 centimeter from the top of the TLC. Right, like this one, you have to draw the line and you make an spot. It should not be greater than the capillary का जो spot है इससे ज़्यादा नहीं होना चाहिए। डेवलपमेंट ऑफ क्रोमेटोग्राम। अब इसके अंदर आप टीएलसी को कैसे रखोगे? क्रोमेटोग्राम इज कीप्ड इन ए टीएलसी टैंक एट एन एंगल ऑफ 45 डिग्री सेंटीग्रेड। 45 डिग्री सेंटीग्रेड के एंगल पे आप रखोगे ताकि आपकी जो सॉल्वेंट की मूवमेंट है वो बेहतर अंदाज में हो सके। द बॉटम ऑफ द टैंक इज नियरली कवर्ड अप टू 1 mm बाय सॉल्वेंट। ठीक है, इसका जो 1 mm से ज्यादा नहीं होनी चाहिए। इसका जो सॉल्वेंट जो है नीचे से, क्योंकि इस लाइन से ऊपर सॉल्वेंट नहीं आना चाहिए। 3 sides of the tank are lined with solvent saturated paper. The top of the tank is covered tightly. इसका जो टॉप है इसको सही तरीके से कवर करना होगा ताकि जो एयर वगैरह जो है इल्यूशन को डिस्टर्ब ना करें। Solvent moves up and separation takes place in ascending way with a few minutes. Just आप डिप करोगे, इसके फ्यू मिनट्स के अंदर आपकी जो सॉल्यूशन की सॉल्वेंट की इल्यूशन जो है वो स्टार्ट हो जाएगी। ठीक है। प्लेट इज रिमूव एंड ड्राइड। इस प्लेट को आप देख लो, अगर ये ऊपर से 0.5 रहता है, ऊपर जो स्पेस है टीएलसी का, तो इस वक्त आपने इसको निकालना है, रिमूव करना है एंड ड्राइड, और इसको ड्राई करना है। द सेपरेटेड कंपोनेंट्स आर लोकेटेड। अब जो कंपाउंड्स है इसके अंदर जो सेपरेट हुए हैं वो आपको ऐसे नजर नहीं आएंगे। इसको लोकेट करने के लिए कि कौन से कंपाउंड कहाँ कैसे सेपरेट हुए हैं, वो हमारे पास 2 मेथड हैं, फिजिकल मेथड एंड केमिकल मेथड। फिजिकल मेथड और केमिकल मेथड से आप इनको लोकेट कर सकते हैं। कौन कौन से हैं मेथड्स? फिजिकल मेथड में, इन फिजिकल मेथड वी आर मोस्ट फ्रिक्वेंटली यूजिंग अल्ट्रावायलेट लाइट, यूवी लाइट को हम इस्तेमाल करते हैं। TLC visualization method है, but there are 2 methods for TLC visualization and physical methods में एक UV light है। UV light से इसका फेनोमेना क्या है? Some organic compounds illuminates or fluorescence under short wave UV light, right? Those organic compounds which have functional groups are double bonds or कंजुगेटेड डबल बॉन्ड्स, वो इसमें इल्यूमिनेट्स या फ्लोरेसेंस शो करेंगे। इसी तरह से हमारी टीएलसी में वो कंपाउंड्स नजर आएंगे। दिस आर द फिजिकल मेथड्स। और केमिकल मेथड्स में वी आर यूजिंग डिफरेंट स्प्रेइंग एजेंट्स टू इंडिकेट द सेपरेटेड कंपाउंड्स। इसमें से 2 अहम वो हैं, एक सीरिक सल्फेट सॉल्यूशन है, वन इज सीरिक सल्फेट सॉल्यूशन for all organic compounds, visualization of all organic compounds, and another is drag and drop reagent. A drag and drop reagent is most frequently used to identify either alkydes or striatal electrons present in your mixture or not. इसके अलावा आप आयोडीन वेपर्स को भी आप इस्तेमाल कर सकते हैं। फ्लोरेसेंट इंडिकेटर्स हैं, इनको आप इस्तेमाल कर सकते हैं। सिल्वर नाइट्रेट स्प्रे कर सकते हैं और सल्फ्यूरिक एसिड स्प्रे करके इसको हीट करके आप इसके जरिए भी कर सकते हैं। बट मोस्ट फ्रिक्वेंटली वी आर यूजिंग इज सीरिक सल्फेट सॉल्यूशन टू एज स्प्रेइंग एजेंट फॉर विजुअलाइजेशन ऑफ टीएलसी। ठीक है। और दूसरा जो है ड्रैगन ड्रॉप हम मोस्ट कॉमनली यूज करते हैं। इसके अलावा सल्फ्यूरिक एसिड स्प्रे कर सकते हैं, सिल्वर नाइट्रेट का स्प्रे आप लोग कर सकते हैं। ठीक है। इसके जरिए हमें पता चल जाएगा कि हमारे कंपाउंड्स जो हैं वो इस तरह से सेपरेट हुए हैं या नहीं हुए हैं। तो हाई पोलर और लेस पोलर कंपाउंड्स जो हैं वो ऑन द बेसिस ऑफ सॉल्वेंट सिस्टम पे ये आपके पास सेपरेशन आ जाएगी। फिर इसमें हम इसके बाद हम जो है इसकी RF वैल्यू निकालते हैं। RF वैल्यू आई हैव ऑलरेडी डिस्कस्ड विद यू। that distance traveled by the substance divided by distance traveled by the solvent. Suppose there are these two compound, we have put a mixture like this one here. Now after development in TLC10, these two compounds are separated. Now you can find out the RF value, that is distance traveled by the compound 1 is 22 mm, that is divided by the solvent front, right, that is 65 mm, which is 0.34, and the compound 2 distance traveled by the compound 2 is 50 mm, and distance traveled by the solvent front is 65 mm. So RF value for compound 2 is 0.77. Remember that RF value never be greater than 1. It must be lower than 1, not greater than 1. Right? So we can identify its RF value like this one. Now we will discuss its some application. कुछ applications के बारे में हम discuss करेंगे. Now UV two-dimensional, we can develop two-dimensional chromatograph, but that is not in our syllabus. We will discuss in it in any other class, right? Application of PLC. Any question till here?
No, sir.
Okay. Application of thin layer chromatography. One is qualitative analysis and another is quantitative analysis. As I have already tell you that what do you mean by qualitative analysis? In simple way, we can say that qualitative means what is actually. Qualitative mean what is actually, and quantitative analysis mean how much it is, right? How much it is, that is called quantitative analysis. So through application by using thin layer chromatography, if the separated components are colored, then identification is very easy. All visualizing agent used in paper chromatography, detecting agent or indicators can be used in TLC, which are physical methods as well as chemical methods. From RF value, qualitative analysis can be performed, right, by two ways. One is spraying agent easily tell us which type of compounds we have, and another is RF value tell us the qualitative analysis. Through RF value, qualitative analysis can be performed, right? So this is the qualitative and application of TLC through qualitative analysis. If we are discussing the quantitative analysis, the size of the spot increase with the amount, right? Square root of the spot area is find out. From that amount of the solute can be found out. So these are not for in your syllabus. Other application of thin layer chromatography. Thin layer chromatography is applicable in the field of medicinal preparation, pharmaceutical preparation, and natural product extracts and a related compound. Thin layer chromatography is also used for assaying the radiochemical purity of radiopharmaceuticals. Thin layer chromatography also used for determination of the pigments in plants, right? If you are in plant sizes or animal sizes, we can easily determine the pigments in different plants, right? In forensic sciences, laboratory detection of pesticides and insecticides in food or poison, we can easily detect by thin layer chromatography by using an standard. एक स्टैंडर्ड लेके इसके जरिए हम चेक करते हैं कि कौन सा पॉइजन इसके अंदर या पेस्टिसाइड या इंसेक्टिसाइड इसके अंदर मौजूद है. So if we can use thin layer chromatography in forensic science laboratory, or as well as in plant sciences, as well as in animal sciences. Other applications of thin layer chromatography: analyzing the dye composition of fibers in forensic study, are identifying compounds present in a given substance. For monitoring organic reactions in clinical study, to carry out qualitative and quantitative analysis of biological and metabolic samples to detect disease, right? What are the advantages of TLC, our paper chromatography? We have already performed paper chromatography, and what are the advantages of TLC, our paper chromatography? Separation is sharper in TLC than paper chromatography, right? TLC is much rapid. The use of inorganic layer eliminates backbone organic effect in spectroscopic analysis. More reactive reagent like sulfuric acid can be used as spraying agent. The separated spots are more distinct, hence the detection method are more sensitive than paper chromatography, right? Any question?
No, sir.
Okay. If you face any difficulty, you can comment in this video.